Do you know how to convert from decimal to binary and from binary to decimal?
Yeah.
Using calculator or manual way?
Okay. Probably calculator.
Yeah.
Let's be honest. No, right. You don't know the Windows calculator?
So hostile.
I always have Chrome.
That's true.
And did you register before in probability theory course?
So. Back they charge $5 for 3 hours and $7 for a day. And the amount of spots there for the hours.
I think no one will join us.
This thing's 6 years old. So yeah, so the battery in this sketch. Okay, I got one. Oh, really? We'll find out.
Okay, that's good. You find charger for your iPad. You found one.
Just sharing.
Yeah.
Hopefully, we'll see. Start down with your iTunes stuff.
Okay, let's start our lecture today. Welcome everyone. Today we will speak about IP addressing. We want to understand the basic concept of IP addressing. Okay. In the next lecture, we will discuss IV subnetting, how you can allocate IV for different users at different networks. Okay, but today we want to understand what is the meaning of IP addressing. Why do I need to use IP addressing? Okay, at first, and let's make it a discussion based on your previous experience. Why do I need IP addressing? Okay.
Know where to send the data or something.
Okay. Okay. The same answer, yeah?
Yeah.
Okay. Anything else? Okay. That's enough. Actually, IP address is your address on the network. Okay. As I know, I used this example several times before. If you want to send a mail, you must write the sender address and the destination address. Yeah. The same here in the communication networks. So IP address is a logical network address that identify a host. Here I use logical network address. If I say what is the physical network address, it will be MAC address. Okay, so every device will have two addresses. The first one is logical address, which is the IP, and the second one is the physical address, which is the MAC address. Physical address, because this address will be your address all the time. It is printed in your network interface card. And here in this laptop, we have network interface card. In your mobile phone, you have network interface card. In your iPad, you have network interface card. In all of these network interface cards, everyone has a unique physical address, unique MAC address, okay? And when you are connected to a network, you obtain another logical address, IP address. And we will see in the coming lectures why do you need to use IP address and MAC address. Actually, you need to use the both, the MAC address and the IP address, okay? To make it simple, you need to use the MAC address as when we are in the same network, we are connecting using the switch. Okay, and here device. Switch is layer 2 device, which means that we can bring this slide outside. Here, this is from our last lecture, okay? Switch is a network device that can be used to connect user devices at the same network. So here in this room, we are connecting over the same Wi-Fi network, okay? We are connected through using the same switch, the same access point, okay? So switch is used to connect devices at the same network, okay? Switch is layer 2 device, so it can deal only with data link layer and the physical layer. In data link layer, if you remember from our last lecture, we make MAC addressing or physical addressing. So switch can understand physical addressing, okay? So we need the MAC address while we are communicating inside the same network, okay? What about the router? Okay, router is a network device that is used to connect the devices at different networks. So at the same network, we can communicate through using switch. If you want to communicate with another device at different network, you should use router. So in this case, we must have router, and this router is connected to another router, and we have another network here, switch can connect multiple devices. So this is network 1, and this is network 2. Okay, so inside this network, we are using the switch, and the switch can understand the MAC address. Okay, if we want to communicate with another device at another network here, for example, this one want to communicate with this one, we need a router to communicate with different networks. Router is layer 3 device, which can deal with network layer, data link layer, physical layer. In network layer, we make IP addressing, okay? And data link, we make MAC addressing. And physical layer, we convert the bits to be transmitted over the chip. So router can understand IP address and the MAC address. Switch can understand only MAC address. Okay?
Isn't there a middle point? Let's say I was trying to ping San Francisco, would I not ping Vancouver's Shaw, if I use Shaw facility, but not a Shaw facility would ping San Francisco? Isn't there kind of that middle point with your ping distribution?
Okay, sorry, again, I didn't get your question.
So if I was trying to ping, let's say San Francisco,
Okay,
I would ping Vancouver and then San Francisco, right? Because I'm using Shaw and Shaw's main facilities in Vancouver.
yes,
So it's not going to go from router to router, it's always going to go router to router to router.
yes. So I will show you an example, okay? Here, I will get the run. Okay. I was trying your example yesterday, okay? I want, for example, to bring, to know the way, how can I reach to the Facebook server, for example, okay? So I write this command in the run, trace cert facebook.com, okay? And I'll hit okay. This will show you your path, the routers that you will move through to reach your destination. So this is the first one. Yeah. This is the second one. This is the second router. Okay. This is the third one. Fourth. Okay. With this is its destination IP address. Okay. 5. Now this is .ca. This is one of the internet service providers. Okay. And you take 10, you must go through 10 routers to reach the Facebook server. I think it is at USA. Okay. So when you are dealing with different, when your bus, you have multiple routers, yeah, your data will move through all of these routers. Okay. So this is the difference between the router and switch. Okay, so again, switch can be used to communicate at the same network. Make devices can communicate at the same network, but if we need to communicate with devices at different networks, we must use router. So here, Okanagan campus or Kelowna campus, here Vancouver campus. So to be able to communicate with Vancouver campus, we must have a router. Okay. Okay. So this is why we need both MAC address and IP address. Okay. So again, return to our lecture topic today. Here, IP address is a logical network address that identifies a host, and we know that in we have our data, we make segmentation, and we add the transport layer header, which is the sequence number, okay, of each segment. And after that, we add data, therefore header. And after that, we add the source address, the source IP address and destination IP address, so we can call it bucket. This is from our previous lecture in layer 3. So each bucket will contain a source and destination address. Your IP address and your destination address must be included in your transmitted bucket. Okay. Okay. Actually, we have two types of IP that we can use. We have IP version 4 and IP version 6. IP version 4 consists of 32 bits. We divide it into 4 octets. This is the first octet, second one, third one, fourth one. Each octet will be 8 bits. So 8, 8, 8, 8 equal 32 bits. Okay. Actually, the way that we can write the IP address is using dotted decimal notion. So we can write the IP address in decimal numbers, for example. So this is an example to IP address. But in fact, in computer language, computer doesn't understand decimal. Computer understand binary, 0 and 1. So computer converts this number to 8 bits, 8 bits, 8 bits, 8 bits. Okay, so we have 32 bits, okay? And each bit can be 0 or 1, okay? So if we want to calculate the total number of available IPs, how many IPs do we have? How can we calculate it?
2 to 32.
Yes, we have two possibilities. 0 or 1, each bit has two possibilities, 0 or 1. So the number of IPs is equal to 2 power 32. Okay, so we have billions of IP addresses, but is this enough?
And so right now it is.
No, not enough. Okay, as now, I think we are 6 billion now. Yeah, 7. 7. 8, 7, 8. So, and everyone, you have your mobile phone and iPad now. I have my mobile phone and laptop. You have also the same. So everyone can use more than one device. Okay, so this iPad has now an IP address different from your mobile. So this is not enough. So that's why we are developing now IP version 6, which will be 128 bits. So massive number of IPs that can be used. And in the near future, IP version 6 will be the standard, will be the used IP. And it's already used at some places. For example, in Japan, at some places in Japan, they are using now IP version 6. Okay.
It's already accessible already. If you go and CMD and type IP, you can see your IPv6, right?
Yeah, it is already available, yes. Okay, but at most countries, they still use the IP version 4. But as I said, at some other countries, they start to begin to assign to each one IP version 4 and the IP version 6. And in the near future, you will be assigned only IP version 6. Okay, so we have two types, IP version 4 and IP version 6, as we can see. Okay, as I told you, we are dealing with binary numbers. IP address is made up of 0 and 1s. Okay, not from decimal numbers. We are using decimal numbers to make it easy for me. So when I ask you, what is your IP address? You will say to me, it is 10.10.9.1. This is very easy. And instead of you are saying, no, it is 0.101.0.0.0.0, okay? And so on. This is very difficult, okay? So we are using the decimal way of writing the IP address to make it easy as engineers, okay? And we already have softwares that can convert from decimal to binary, to the language that computer can understand. Okay, so I think it's easy for you to convert these examples, yes? So how can we do it manually? We have 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 7, okay? 2 power 0 is 1, 2, 4, 8, 16, 32, 64, 128. Okay, and we want to convert 128 92. Okay, so at first, is 192 greater than 128? Yes, so I will put here 1 and subtract 192 from, okay, so it will equal 64. Okay, yeah, 64, yeah. Okay, so the second is 64 greater than or equal 64? Yes, so I will put 1 here and subtract both of them. It will equal 0. So we are finished. 0, 0, 0, 0, 0, 0. Okay. You can have different ways to convert from binary to decimal, but this is one way to convert. Okay, from the decimal to binary. And again, if you want to calculate this number, so we have here 1, 0, 1, 0, 1, 1, 1. So what you have is to add 1 plus 2 plus 4 plus 16 plus 64 plus, okay, to convert to this. This is easy for you. Okay, you can try by yourself these examples. I think it's very easy. Okay, so now we know that the IP address version 4 consists of 32 bits, and we can divide the 32 bits into 4 octets, and each octet is 8 bits. Okay, okay. The IP address consists of 2 parts: network part and the host part. It is like your name. Your name consists of 2 parts: your first name and your last name. Your last name is your family name, which is your network name. Okay. For example, here at this campus, okay, we have a network for the financial department. Okay. And we have a network for engineering department. And we have a network for sales department. And we connect between all of them, so using router. Okay, so the family name of this network is the engineering department. Inside the engineering department, we have different users that are allocated to this network. We have the sales network. Okay, so we, as I told you, the IP address consists of 2 parts: network part, family name, and host part is the username. The family name for each network is fixed. Okay, but we change the host name. For example, here we are connected to the same network, so the network name is the same for all of us. But you have different host part, and you have different host part, and you also have different host part. Okay, so if you can see your IP, can you see your IP now? Let's see all.
142.231.80.232.
One what?
142.231.
1 second. What? 231?
Yeah.
80.
232.
Okay. So as you can see here, the first queue the first two octets are the same. So this is our network part. This is our network name. Okay, and we have different host part. Okay, so we can divide this IP address into family name, which is this one. This is the network name, and host name. So my host name for sure must be different from his host name. But as we are connected to the same network, we must have the same network name. This is clear for you? Okay. Okay.
Why are internal IPs always starting with 192.168?
Why what?
Like internal IPs when you're trying to, like your gateway. Why is it always 192.168?
192.168. Okay. Okay. Actually, we will discuss this at our next lecture. But for you now, okay, we can classify IPs to private IPs and the public IP. Okay, so 192.168 is one of the examples of private IPs. In order to save IPs, okay, we can communicate at the same network using private IPs. Okay, as actually we don't need to use IPs in communication inside the same networks. So we don't need to consume IPs for something that we don't use. But you must have IP address and MAC address in order to complete your frame. There is part for source IP address, and there is another part for destination IP address. Okay, so in order to save IPs, we allocate some of private IPs that can users reuse. So here in this network, you can take 192.168.1.1.2, for example. Okay, and in another network, there is another user can take the same IP address, 192.168.1.2. Okay, how you are communicating? You have the same IP address actually. For fact, you are not communicating using this IP address. This IP address is used only when you are communicating inside the same network. Here, if this device is communicating with this device, actually they are communicating through using switch MAC address. But you still in your frame, there is field reserved for IP addresses. So I must allocate to you IP address. Okay, so here we assign some of IPs to be used as private IPs, okay, that we can use inside our network, okay, inside our network, and it can be reused at another networks. But what if you want to communicate with another device at different network with the same device, this one, okay? Actually, you have public IP address, okay? You have public IP address, okay? So at this moment, you will use your public IP address, okay, to communicate. For example, here, okay, we have lots of examples. If I want to write here, what is my public IP address? Okay, and yeah, I will select this one. Okay.
So is your public IP linked to your router then, and it has private IPs within the network, and then it's all linked back to your router, or is every single device in your network has its own public IP?
Actually, it depends on how rich we are. For example, here at UBC, I think we are rich, so they assign to you a public IP address, no private IP address, okay? But at your home, we are not rich, so we are using private IP addresses. And all of the devices at the network can use the same public IP address. So at your home, all of your network your mobile, your laptop, your printer, your server, your brother mobile, for example, your sister laptop, all of you can communicate using one public IP address. Okay, so we can allocate to you one public IP address. And how we can know that this traffic is going to you, not to your brother, okay, through using the MAC address. Okay, so in this case, we are using one IP address, okay, one public IP address, okay, in order to reach to the network. Okay, so your network has one public IP address. Okay, so here, when the data reach to the router, okay, it will see your public IP address. So the router, as the router understands IPs, the router will know, yes, this is the public IP address of the sales department. So I will forward this data to the sales department. So your packet will reach to switch. The switch doesn't understand IP. The switch understands the MAC address. Okay, so the switch will check the MAC address, which will be your MAC address. Okay, so yes, this is the packet of this device. So I will forward it to this device. You understand this? Is this clear for you? Is this clear? Okay. Actually, communication networks has many questions, and yeah, ask. Okay, returning back to our lecture. Okay, so how can, so till now everything is clear to you? Okay. How can you know your network part, your network name, and your host part? For example, here, as I remember, 142. No problem. Okay, 132. Okay, 19.1, for example. Okay, this is my IP address, and to make it more easy, as at your home. Okay, this is my IP address, and I want to know what is my family name, what is my network name, and what is my host name. Okay, so how can we do it? From using this IP, I can't know it. Okay, so we can know what is my network part and what is the host part through using something called subnet mask. Subnet mask must be associated to each IP address. So when you are forward your IP address, you must associate it with its subnet mask. Okay, so why? To enable the router to know what is the network, what is your network name, and what is your host name. Okay, how can we do it? Subnet mask is also 32 bits. Okay, can also written in dot decimal notation. It's like the IP address, but in subnet mask, it consists of sequence of ones, and after that, sequence of zeros. So an IP address, you can have 101.110, something like that. Okay. In subnet mask, no. You will have sequence of ones, and after that, followed by sequence of zero. Okay. The number of ones in your subnet mask represent the network part, and the number of zeros in your subnet mask represent the host part. Okay, so how can we do it? You make and byte and, you can make and or these operations, yeah? Make and between your IP and the subnet mask, you can get your network name. Let's try it. Here, what if I tell you in this example here, we have 144, and your subnet mask is 255.255.255.0. Okay, and I want to know what is the network address. So the first step, convert this IP address to binary. Okay, so we can do it 1100000 dot. This will be 101, and yeah, it is already written here. So we convert, this IP address to binary, as you can see here. Okay, and we convert our mask to binary, as you can see here. Okay, 25.5, remember 25.5 is 8 ones. Okay, dot 8 ones. Okay, so make and process, binary and process between these two binary sequences. What will you have in binary? 01, 01, 00, 11. 0 and with 0, 0. 0 and with 1, 0. 1 and 0, 1. Okay. So here, after making that AND process, you will find that your network address will be this, and with this will have this result, this and with this will have this result. If you make this AND process, you will find that your network address is 1. This is your network address, okay? After making this AND process. If we take another example with different IP address and make the same AND process, we will receive the result that we are at the same network. How can you know that we are at the same network?
Same IP.
The same network address, the same family name. Okay. After you make AND between your IP and the subnet mask, the network address that you obtained is the same as the network address that you obtained in our previous example. Okay.
I thought it was the first two 32, like the first two 8 bits that are the network address, and the second two are the
Okay, first two what?
like the first two 8-bit, like the first 2 bytes, they're the network, right? Not the third one.
Okay, here.
So why are we doing that?
Here in our example, we have the first 3 octets are the network part, and the 4th octet is the host part. This is here in our example. In other examples, you may obtain the first 2 octets as in our previous example here, the first 2 octets were the network part, and the 3rd and the 4th were the host part. It depends on the IP class, as we will see in our next slide. Okay.
Can you have it change from being the network to the host address in the middle of an offset?
You ask if can we change the network part?
Well, no, like say for instead of the mask being 255, 255, 255, so we have 255, 255, and then what is that? So it's F for it.
Okay. Yeah, we can you ask, can we have different numbers from 255?
Yes.
Yes, and this is what we will see in IV subnetting. Okay, So in IP, what we do in IP subnetting that we change in the subnet mask. Okay, so in the we enable the subnet mask to have different numbers from 255 to 255. Okay, so you will see this in examples, many examples in our next lecture. Okay, so you understand the basic idea of the subnet mask. So when you send your IP address, you must send your subnet mask to enable the router and the receiving device to know what is your network name. Okay, by making binary AND between your binary IP address and your binary subnet mask, you will receive your network address. And if, for example, for you, actually you don't know if the device that you want to communicate with is in your network or on another network. You don't know this. Okay, so for example, if you are here at UBC and you want to send a message to him, okay, maybe he now is at UBC, so you are now at the same network. Okay, at other moment he will return to his home, so he will be at different network. You don't know his location, you don't know his network. Okay, so you want to know if your friend or the device that you are communicating with is at the same network or at different network. What should you do to make AND process between his IP address and his subnet mask? You will receive his network address and make AND process between your IP address and your subnet mask address. Okay, and you will receive your network address. If the result is the same, so you are at the same network. If you have different results, different network addresses, which means that you are at different networks. Okay, so we use the IP address and subnet mask address to know if the device that I communicate with is at the same network or at different network. Okay.
Why couldn't we just add them together? Like, why couldn't we just add two? If we were checking the first the first 2 bytes, why couldn't we just add 2 addresses together and then check if they're the same?
That you must make the AND process to know that to know that if this IP address is with you at the same network or at different network. As you will see in the next slides, we divide IP addresses into classes, and each class has its own subnet mask. Okay, and in the next lecture, you will see that we will not use the default subnet mask. We will change the subnet mask. So subnet mask is not fixed; it's changed. Okay, so at every time you need to confirm that this IP address is with me at the same network or it is at different network. So the AND process between the subnet mask and the IP address is mandatory process to know the device that I communicate with is with me or at different network. Actually, we divide the IP addresses into class A, B, C, D, E. Okay, and if I want to ask you, what is the first IP address? Yes, we have 32 bits. The first IP address is to have 0.0.0.0, and the last IP address. Yes. Okay, so this is the range of the IP addresses. Okay, we divide this range into some classes. Each class has its own properties. Okay, the range, the first range from 0.0.0.0
until we reach to 0, 255, 255, 255
is reserved for something called gateway. What is the gateway? If you can turn back here and we can share here. Tell us what is our gateway. DNS. Okay.
It'll tell you.
Yeah. I here open what?
Just go to search bar, type C.
Okay, I can.
That works.
No. Okay, it was not gateway.
Do you want the gateway we're using?
No, I want to know what is my
Just do IP config.
Yeah, here in Zaran. Okay, I can know it
Yeah.
from Zaran. Okay, but in Windows 8 and Windows 7, it can, yeah, in the past you can see it here. Okay, so what is the gateway here? Here, actually, the router at your home is not intelligent enough. The router at your home can't make routing. Okay. It is very simple device. It is not as the routers that are used at internet service providers or at the big companies or at the bank, hospital. No, it is very simple device. You now at your home and you want to send a message to another one at different destination. So you will write your message and click send, and your data will be forwarded to your router. Your router will see your source address, okay. The destination address, okay. How can I reach to this destination address? I don't know. Why? As I am not intelligent. Okay, what should you do? I will forward all of your packets to another device which will be more intelligent than me. So it will forward your data to your internet service provider. Okay, and at your internet service provider, you will see that, okay, the routers at your internet service providers are more intelligent, so they can make data routing and they will deliver your data to your destination. Okay, what is this process? This process is called the gateway. So your router at home is your gateway to communicate, okay, with other world, with other devices. Okay, if your router doesn't know how to deliver your data to the destination, it will forward your data to more intelligent router, okay, that can make data routing. And this is the process that happens at your home. Okay, so that's why we reserve this range to be allocated to gateways. We call it default gateways. Okay, so for commercial use, we start our IP addresses from from 1.0.0.0, okay, to 126, 25.5, 25.5, 25, 200, sorry for that. Okay, so this is the first range. We call it class A. Okay, in class A, we assign the first octet to be the network part, and we reserve the other 3 octets to serve for host part. Okay, so don't see this. How many? Okay, no problem. Okay, how many users can IP address, range of IP address in class A serve? We have in our IP address 32 bits. Okay, we reserve the first 8 bits for the network part. So our mask will be 255.0.0.0. Yes, as this represents the network part, 8 ones, and we have 24 zeros. So this 24 zeros, okay, represents the host part, and these 8 ones can represent the network part. How many users can serve using one IP address range? We have 24 bits reserved for the host part. So each network can have at the same time 22 power 24 host part, okay, host device, okay, at the same time. Actually, we subtract 2 from this number because at each network range, the first IP address represents the network address. No one can use it, okay? For example, my name is Mahmoud Hasab al-Nabi. My family name is Hasab al-Nabi. I can't call my baby, for example, Hasab al-Nabi, Hasab al-Nabi, Hasab al-Nabi. You can do it, but okay, this is something weird, yeah. So no one can use the network address, okay? And what about the last IP address? No one can't use it. Why? As we reserve it to be used as broadcast address. If I want to send all of you a message at the same time, I don't have to send to you this message, and after that it changes the destination address to your destination address to send to you the same address, the same message, and after that I will have to change my destination address to send this message to you, and why? I consume times. So at each IP range, there is one IP reserved for broadcast addressing. I will use this IP when I bought this IP in my packet, okay? This means that I will forward this message to all the devices at my network, okay? So for example here, if I want to send to you one message at the same time, I will put a destination address, the broadcast address, okay? And also in MAC address, I will put broadcast MAC address, okay? So this means that this message will be forwarded to all of you at the same time. So the first IP address and the last IP address we can't use. The first one is the network address and the last one is the broadcast address. So here we have 24 bits allocated to class A IP address range, so we can serve 2 power 24 minus 2. Okay, so when we calculate this number, it is around 16 millions. It is very large number, so we can use it to serve large organizations. Okay, okay. The last note, we from 127.0.0.0 to 127.25 is reserved to something called loopback testing, and I will show you in our next lecture an example to how to make loopback testing. Okay, from the same as the same, what we do, we have class B. Okay, in class B we reserve the first 2 octets for the network part and the third and the fourth for the host part. So here we have 16 bits can be reserved to the host, to the number of users can we serve using class B IP address range is 2 power 16, and we subtract minus 2 as we reserve one for network address and one for broadcast address. So we can use it for that median size organization, and the subnet mask will be 255 to 255 to 00. And in the last one, yeah, only 1 minute, okay? Okay, and the last one here in class C, we reserve the first 3 octets to the network part, and only the 4th octet to the host part. So here, how many bits here? 8. Number of devices can serve using one IP range from class C is 2 power 8 minus 2, so it will be 254. So we can use it in small organizations. We have class D and class E. Actually, we don't use them for commercial use. For class D, we use it for multicast. What is the meaning of multicast? If I want to send a message to a group of you, not all of you, I will select some of you, and I will allocate to you multicast address. For example, I want to send a message to this part only. Okay, so I will send to you only. I will put a multicast address, and I will assign to you multicast address. Okay, so we can communicate only at the same time. And for class E, it is used for experimental use for the companies that developed the IP addresses. It reserves this range to make some experimental use. Okay, this is the distribution of classes that we can have in IP addresses. In our next lecture, we will discuss together how to change the subnet mask to optimize the use of IP addresses. Thank you, everyone. Remember, next Monday we will have a lab, okay? And you must submit your pre-lab before the start of your lab. You can submit it on paper, write your solution on a paper, or you can, if you want to submit your solution in a Word file, for example, you can forward your solution to me, okay, to my email, okay? Thank you, everyone.
Thanks.
Okay, we can.